Hi everyone, let's see another problem on mathematical induction. So the problem is 2n plus 7 is less than n plus 3 whole square for all n belongs to capital N. So we have to prove this statement. So let us first consider the statement, that is Sn is the statement is 2n plus 7 is less than n plus 3 whole square for all n belongs to capital N. Now to prove this statement we have to check on for n is equals to 1 in the first step. So for n, substitute n is equals to 1. On substituting n is equals to 1, we will check out the LHS part, that is 2n plus 7, which is equals to 2 of 1 plus 7. 2 into 1 plus 7, that is 2 into 1 is 2 plus 7 is equals to 9. RHS part is n plus 3 whole square, which is equals to 1 plus 3 whole square, which is equals to 16. So 9 is clearly less than 16. Now we can say that the statement is true for n is equals to 1. Now we have to assume that the given statement is true for n is equals to k. So on assuming that 2k plus 7 is less than k plus 3 whole square. Now in step 3 we have to prove that the statement is true for n is equals to k plus 1. Consider 2 of k plus 1 plus 7. So we have to consider this number. Saying instead of k we are substituting k plus 1, okay, and we are just considering LHS part, and by considering that we have to prove it that this particular value is less than k plus 1 plus 1 whole square, that is k plus 4 whole square. So let's see how do we do that. So 2 of k plus 1 plus 7 is equals to 2k plus 2 plus 7, which is equals to 2k plus 9. Now you have to get in such a way that 2k plus 7 you can keep it as common. 2k plus 7 plus 2. Now you can say that 2k plus 7 is clearly less than k plus 3 whole square. So it is less than k plus 3 whole square. But here 2 is also there. So add 2. So this whole value is less than k plus 3 whole square plus 2. That means 2k plus 7 plus 2 is less than k plus 3 whole square plus 2. So the whole criteria of writing this is that 2k plus 7 we can say that k plus 3 wholes, it is less than k plus 3 whole square, right? So that we are substituting over here and plus 2. Then after that the statement 2k plus 7 plus 2 is less than, on expanding we'll be getting it as k square plus 6k plus 9 plus 2. So 2k plus 7 plus 2 is less than k square plus 6k plus 11. So now this whole value we have to get it in terms of k plus 4 whole square, okay. For that we'll be adding and subtracting certain value. Let's see how. Yeah, so on doing so we'll be getting it as 2k plus 7 plus 2 is less than k square plus 6k plus 11. So for this value we are adding and subtracting 2k plus 5. So 2k plus 5 minus 2k plus minus 2k minus 5, okay. Now on adding 2k plus 5, this equation is becoming like k square plus 8k plus 16. It is somewhat like k plus 4 whole square, right? So k plus 4 whole square minus 2k plus 5. Now if you see that this value is smaller, okay. How it is smaller? It is smaller than k plus 4 whole square. So if we close this part, okay, will be remain with k plus 4 whole square. So the whole value on the right hand side, on the left hand side, that is 2k plus 7 plus 2 is already less than this value, okay. From this value we are subtracting this value and we are getting some value as k plus 4 whole square minus 2k plus 5. So this value is already less than this whole value. So if we remove this value also, on removing this value also, the whole value will be less than k plus 4 whole square. Okay, let's take an example saying that 3 and 4. So 3 is less than 4. Three is less than 4, and suppose here it is 4. So on removing one value, that is, let's suppose 1. So on removing one value we'll be getting it as, if we remove if we remove one value from this whole value, we'll be getting it as 5. If we remove this value, for example, this whole value is 4, that means this value is 5 and this value is 1. 5 minus 1 is 4. So if we are removing minus 1 from this part and we are just keeping 5 as it is, so again 3 will be less than 5. So the same way, on removing this part also, this whole equation on the left hand side, it will still be less than k plus 4 whole square. Okay, so it is less than k plus 4 whole square, which is less than k plus 1 plus 3 whole square. Okay, so now you got in terms of k plus 1, right? So you can say that the statement is true, therefore s of k plus 1 is true by the principle of mathematical induction. Therefore the statement is true for all n small n belongs to capital N. Thanks for watching. If you have any doubt, please do comment in the comment section. And if you did not understand this part, I'm just writing it as, let's suppose here on the left hand side is 3, which is less than 5 minus 1. So on removing this minus 1 also, 3 will be less than 5, right? So the same concept here we have applied. Okay, thank you so much for watching. Please do comment your doubts in the comment section.